Hi students, today we will got very important concepts for higher sections. When you go for 10th class, these concepts are very important. See student, today we will learn the laws of exponents and the student will apply these formulae to solve the problems. Look students, what you are seeing here on the screen. What is this? Yes, you are right. This is the earth. And what you are observing? The sun also. Do you know what is the distance between the earth and a sun? Do you know what is the distance between the sun and the earth? Think everyone, think carefully. It is 15 crores kilometers. See how long, how we can write these numbers. See, look at the number, how much big it is. 15 crore kilometers, isn't it? Do you know what is the population of India according to 2001 census? It is 120 crores, isn't it? This number is also very big. It is very difficult to write this type of numbers. See here, putting zeros like this and writing this type of numbers is too lengthy and is very difficult to read also, isn't it? So writing this type of numbers is too lengthy. How to decrease the length of a number? Like, let us see. Here 100 can be written as 10 into 10. How many tens are multiplied? 2 tens. Therefore, we can write like 10 to the power of 2. See here 1000. In 1000 how many zeros are there? 3 zeros are there. So 1000 can be written as 10 into 10 into 10. So you can write it as 10 to the power of 3. Like this 10, if you multiply for m times, 10 into 10 into 10 into like so on up to m times, can be written as 10 to the power of m. Look here, a is multiplied m times. So you can write it as a to the power of m. Like 15 crores can be written as 15 into 10 to the power of 7. Like here, see 120 crores can be written as 12 into 10 to the power of 8. See, these type of numbers which are very lengthy, while writing it takes more time, isn't it? Therefore, is there any way to compress these type of numbers? Very large numbers are easier to read and write and understand them when they are expressed in an exponential form. So if you express in an exponential form, you can easily write them and you can easily read them and you can easily understand them also. See here a to the power of m. This a we call it as a base and m we call it as exponent, and we'll read this one as a raised to the power of m. So you all use pencils in your daily life, isn't it? When you go to school, you take pencil box and books, everything to school. So like this, the pencil box is there and the pencil box contains 32 pencils. Can you express this in an exponential form? See, like this, a pencil box is there. How many pencils are there? There are 32 pencils. Can you express this in an exponential form? Is it possible? Yes, 32 can be written as 2 into 2 into 2 into 2 into 2. That is, how many 2's are multiplied? There are 5 2's are multiplied. So you can write it as 2 to the power of 5. And 2 to the power of 5 is an exponential form for 32. So 32 can be represented as 2 to the power of 5, or you can say 2 raised to the power of 5. Let us see here what you are observing on the screen. 8 into 4. Now 8 can be written as 2 into 2 into 2, and 4 can be written as 2 into 2. Now how many 2's are multiplied? How many are there? There are 5 2's. So we can write like 2 to the power of 5. Now we group like this. We group 3 2's and 2 2's like this in this way. 2 into 2 into 2 can be written as 2 to the power of 3, and 2 into 2 can be written as 2 to the power of 2. Now here, when you look at the RHS, it is 2 to the power of 5. So we will make it equal to 2 to the power of 5. So how did you get the 5 here? See here. We get this 5 when we add this 3 with 2. So therefore 2 to the power of 3 into 2 to the power of 2 is equal to 2 to the power of 3 plus 2. When bases are equal and the exponents are different and multiplication is there in between them, you can write like a one base and you can add the exponents. A to the power of m into a to the power of n is equal to a to the power of m plus n. This is the first law. Now let us solve one problem here. See here, I have given one problem and I have left out one blank space. Can you observe it? One bracket I have kept here. What is the number in the bracket? What will be there in the bracket? Can you imagine? Think, children, think. Let us start. Think. I'll give 5 seconds time. See here. Now I'll tell the answer. See. The answer is 5. When we add this 5 with 3, you will get 8. So according to the first law, a to the power of m into a to the power of n is equal to a to the power of m plus n. So the powers are added up like this. So 5 should be there. Now look at this problem. There is a division in between these two exponents. Now let us solve this problem. 3 to the power of 6 can be written as 3 into 3 into 3 6 times, and 3 to the power of 4 can be written as 3 into 3 4 times. So when there is a same number in the numerator and the denominator, the same numbers will cancel like this. So 4 3's will cancel with 4 3's, and how many 3's are left out in the numerator? So 3's are multiplied 2 times. So you can write 3 to the power of 2. Now look here. How did you get the 2 here? You can write like a 6 minus 4 also. That is equal to 3 to the power of 2. So here 3 to the power of 2 and 3 to the power of 2 both are equal. So the bases are equal. The bases are 3 here, and the powers will subtract 6 minus 4. You will get it is equal to 2. Now the second law, a to the power of m by a to the power of n is equal to a to the power of m minus n if m value is greater than n. Let us solve one problem now. So what is the number in the bracket now? Think, students. Think carefully. I will give 5 seconds time, and your time starts now. Over. Your time is up. Now did you get the answer? Now I'll display the answer now. So the answer is 5. How did you get 5 here? Why not 4? Let us see. See, right side 7 to the power of 3 is there. So the exponent is 3. So how did you get 3 here? When you subtract 5 from 8, you will get 3. So the number in the bracket should be 5, like this. Now look at this problem. 2 to the power of 3 and whole to the power of 2. Now we'll solve this problem now. The exponential form which is there inside the bracket, what is there? It is 2 to the power of 3. Therefore, 2 to the power of 3 can be multiplied like this. So 2 is multiplied 3 times. Now we'll write like this first of all. And observe here, bracket is there. Bracket should multiply how many times? 2 times. Like this. That is, the bracket which contains 2 into 2 into 2 should repeat how many times? 2 times. Now, how many 2's are there? There are 6 2's. So, the answer is 2 to the power of 6. So, here 2 to the power of 6 means 3 is multiplied with 2. Then only you will get 2 to the power of 6. So, with this, we'll move on to the next law. That is a to the power of m whole to the power of n is equal to a to the power of m into n. Now we'll do one problem. So what should be there in the box here? Look carefully. What number should be there in the box? Your time starts now. 5 seconds time. Time is up. The answer is 3. So, how did you get 3 here? 2 is multiplied with 3, then only you will get 6. So, here in this box, there should be 3. Next, a to the power of m into b to the power of m is equal to ab whole to the power of m. This one, see here. The bases are different. Till now we observed the problems where the bases are equal. Here the bases are different whereas the powers are equal. Look here. So 2 can be written as 3 times and 3 can be multiplied 3 times like this. Now we will group like this. See here. And we can write like this. 2 into 3 into 2 into 3, 2 into 3. How many 2 into 3 brackets are there, ma? There are 3. When the bases are different and the exponents are equal, you can multiply the bases and you can put one exponent like this. So this one, 2 to the power of 3 into 3 to the power of 3. When the bases are different, the powers are equal. Look here. So we can group the bases, we can multiply the bases and you can put one power like 3. The bases are different. Look at the powers. Are they equal? Yes, they are equal. 2 to the power of 5 by 3 to the power of 5. Now let us solve this type of problem now. 2 to the power of 5 can be multiplied 5 times like 2 into 2 into 2 into 2 into 2 like this, and the denominator is also 3 to the power of 5 is there, so 3 is multiplied for 5 times. Now we'll separate them like this. 2 by 3, 2 by 3, 2 by 3, 2 by 3's. How many are there? There are 5 2 by 3's. So this one you can write like 2 by 3 whole to the power of 5. So here in this problem, when the bases are different and the powers are equal, when division is there in between them, you can put a bracket and you can put one exponent. Let us solve one problem here. 4 to the power of bracket is there by 5 to the power of bracket is there. Right side RHS you see carefully, 4 by 5 whole to the power of 2 is there. So what should be there in the bracket now? What should be there? Which number should be there in the bracket? Come on, quick. Think students. I'll give 5 seconds time. Over? The answer is 2. What will be the answer if any number raised to the power of 1 like 5 to the power of 1 and 7 by 3 whole to the power of 1? You will get the same number. A to the power of 1 is equal to A, where A should not be equal to 0. What will be the answer for any number raised to the power of 0? 6 to the power of 0 is there. So 0 can be written as 1 minus 1. Isn't it? Plus 1 and minus 1 will get cancelled and you will get as it is 0. So there is a negative sign in between the exponents. You can write like this in a division form. A to the power of m minus n can be written as a to the power of m by a to the power of n. That is 6 to the power of 1. You know it is 1. 1 by 1, that is equal to 1. A to the power of 0 is equal to 1, and the condition should be a should not be equal to 0. Till now we have worked out the positive exponent problems, isn't it? Now there is a negative exponent is there. So how we can write such type of problems? See here, 2 to the power of minus 5 is there. Look at the exponent. It is a negative number, minus 5. Let us find out here. We are multiplying this 2 to the power of minus 5 with 2 to the power of 5 by 2 to the power of 5. We are multiplying and dividing. Okay. Now what happens? 2 to the power of minus 5 into 2 to the power of 5. See here, there is multiplication is there in between two exponents, isn't it? So according to this law, if multiplication is there and the bases are equal, what happens to the exponents? They will add up, like minus 5 plus 5. You will get 2 to the power of 0 in the numerator. And you know what is the answer for 2 to the power of 0? Is 1, because you know a to the power of 0 value is 1. Therefore, 1 by 2 to the power of 5. So ultimately you can say that 2 to the power of minus 5 can be written as 1 by 2 to the power of 5. That is, if negative exponent is there, you can write like 1 by 2 to the power of 5. This is a to the power of minus n is equal to 1 by a to the power of n. You can write like this. Now I'll give one problem. Think students, I'll give again 5 seconds time. Yes, time is up. Now I'll tell the answer. Minus 2. Very small numbers can be expressed in a standard form using negative exponents. In our daily life, do you know what is the thickness of this hair? Tell me, think over. I will tell. The thickness of this hair is 0.000005 meters. See how much small it is. This can be written as 5 into 10 to the power of minus 6. So look at this. The exponent is negative. Again, look at this. This is a microfilm. Do you know what is the thickness of this microfilm? This is 0.000015 meters. So this can be written as 1.5 into 10 to the power of minus 5. So indicating a number in an exponential form with a negative exponent. You may get problems like expressing this type of problems. What is the picture you are observing on the screen? Can anyone guess what is this? Your biologists may show these type of pictures. It is a bacteria. Do you know what is the size of the bacteria? It is 0.0000004. So this can be written as 4 into 10 to the power of minus 7. Now this is a sun rays. Early morning sun rays. Very good picture. Do you know what is the diameter of the sun? It is almost 140 crores meters. And this can be written as 1.4 into 10 to the power of 9. See here again, this is this light. Do you know what is the speed of light? It is 30 crores meters. This can be written as 3 into 10 to the power of 8 meters per second. If the bases are equal, then the exponents become equal. Like a to the power of m is equal to a to the power of n, bases are equal. the exponents will become equal. When the exponents are equal, then the bases become equal also. Here the exponents are equal. So what happens? The bases will become equal. This you have to remember, and these type of concepts may be useful while solving problems in your higher classes, like when you go for the 10th class. So these type of laws of exponents and all come through. See, in 10th class, one chapter is there, real numbers. In that, the logarithms chapter is also there. The logarithms concept is there. In that, we will apply all these laws of exponents. With the help of this knowledge, you can fastly solve the problems. Now we'll do some problems. See here, 5 to the power of 6 into 5 to the power of 2x is equal to 5 to the power of 10. Now here you have to find out the x value here. You can, when the bases are equal, the powers will add up. So you can write like this, isn't it? See, the bases are equal, and there is a multiplication is there in between two bases. So the powers will add up. Like this you can write. When the bases are equal, the powers will ultimately make equal. 6x plus 2 is equal to 10. And here, when you bring 6 to the other side, 10 minus 6, you will get 4. And when you take 2 to the other side, it will become 4 by 2. So the 2 is the answer. Now in this problem, 16 can be written as 4 square. See here, two bases are 4. So we have to make 16 also with the base like 4 here. So 16 can be written as 4 to the power of 2. According to this law, you can write 4 to the power of 2 whole to the power of minus 2 like 4 to the power of minus 4. And you know 4 to the power of 0 value is 1. And here a to the power of m into a to the power of n law, according to this, the powers will add up 4 minus 4, and 4 minus 4 is 0, a to the power of 0 value is 1, so this is 1. Okay, expressing 27 whole to the power of minus 4 with base 3. 27 can be written as 3 into 3 into 3. In place of 27, you can write 3 into 3 into 3, and the power is minus 4. So how many 3's are multiplied? 3 3's are multiplied. A to the power of m whole to the power of n is a to the power of m into n, and this can be written as 3 into 4, that is 12. So 27 whole to the power of minus 4 is 3 to the power of minus 12. Now you all students will get more confused while solving the problems. So which problem, which law we have to apply and how to solve the problems, it is more confusing, isn't it? Resolve your confusions now. Let us match now. This is test of your knowledge. See, first problem is connected with law. Do you guess? Can you guess, ma? Yes, this is this law. And the second problem, this is this law, a to the power of m whole to the power of n. And the third one, we have to apply this. So bases are equal. So division is there between. And this problem, so this is the bases are different, whereas the power is same. And look here, negative exponent is there. This one we have to. So this is more useful while solving the problems. Let us recall what we have learned today. A to the power of m into a to the power of n is equal to a to the power of m plus n. A to the power of m by a to the power of n is equal to a to the power of m minus n when m value is greater than n. A to the power of m whole to the power of n is equal to a to the power of m into n. A to the power of m into b to the power of n is equal to ab the whole to the power of m. A to the power of m by b to the power of m is equal to a by b whole to the power of m. See here, a to the power of minus n, negative exponent is there. So you can make it positive while writing this same thing in the denominator, that is a to the power of minus n can be written as 1 by a to the power of n. A to the power of 1 value is a, and a should not be equal to 0, and a to the power of 0 is equal to 1, and here also a should not be equal to 0. Evaluation, students, you have to solve all these problems and you have to work out with the knowledge of these laws of exponents. You have to work out all these problems and you have to show the same thing to your teacher. Okay, students, till now we have learnt the very important concepts in mathematics. When you go for higher education, when you are in 10th class, these laws are very useful for you, and when you practice these problems, when you get awareness of these problems, then only you can solve the problems. So these problems you have to work out and you have to show to your teacher. Thank you.